Good morning, good afternoon, good evening, everyone. Thank you very much for taking time out of your day to spend it here with us. Thrilled to have you here, and hopefully, we can get a chance to connect and get to know you, not just in the session, but beyond the session as well. And as Bill mentioned, we are going to take a scenario of a walk through a real world production project, and we'll step through what that last mile looks like in a scenario that we have here. So we've done the introductions. I won't belabor this point, but the one thing I will add is that my most rewarding role that I had at Microsoft was the developer community and relations role. I got a chance to meet and connect with developers, engineers, and data scientists like yourself, both in the professional space and also in the higher ed space. And it always humbled me to see how you were approaching and solving challenges using the technology in creative ways. So great to be here, and looking forward to meeting you. As we talked about, we will walk through a scenario that will take that last mile of ML and show how you get into production. The scenario that we will go through is a real world challenge in the credit card fraud space. And this is a space that has seen a number of challenges, historically, but also in recent years. Credit card fraud cost payment companies over $24 billion in the US alone and affected 23 million US citizens. You can compound that by, the global stats, and you can see how big a challenge this is for credit card payment companies to use technology to help combat this fraud and protect their customers and their businesses from these situations using technology, security, and AI detection. So, for example, Visa are investing $9 billion in that tech security and AI detection space, and they are looking to teams of data scientists and engineers to help take the data and the research that they have and put that into production for the benefit of their customers. And so what we'll step through in this example is those current pain points and those blockers to production. We're just two people, so we'll cover two personas, but in a real world scenario, you might have multiple players in this space that are part of that team. And we will go through that model collaboration, creating the workspace, uploading, deploying the models, checking that health for sustainability and durability, and also then getting into looking for those anomalies that we can action on for the benefit of the business. You can also run through some tutorials like this and others if you go to our free community edition, download that, and you can play along in your own time with your colleagues. And I'll go into that a little bit more detail later on at the end of the session. But to begin with, we have the scenario that we have here is that last mile. And so the company, the credit card company, has been through that insight creation. They've ran through, prepping the data. They've done the R&D. They've trained their models, and now they're at a stage where they may need to realize the value of that data that they have. And in a real world scenario, this is important. This is no small feat for the company to get to this point. I was involved in a project last year with a large grocery chain company, where we were using AI and ML to analyze the fresh produce that they have in their stores. And so we started with bananas, we had strawberries and leafy greens as our product set to start that project. And so we had to then, get that team together. We had specialists within the Microsoft company. We had the tech specialists and other data scientists within the customer as well. And it took us 6 months to get to the point where we were ready to deploy. And those were things like, running through the R&D, setting up a store environment, taking the model training of, is the product underripe? Is it overripe? Is it bruised? We also had a digital nose for the strawberries that could detect mold happening. And then the other models that we had to take into consideration were the microclimates in the stores across the country. Some stores were in humid areas, some were in dry climates, and we had seasonal climate as well within the store, or windows that had south facing and the sunlight was shining into that produce area. So that's a complex situation and costly to a business to get to that point. But what we need to do to realize the value of that effort and that expense to the business is to take that experimental data and industrialize it, to make it real for the business so that they can then start to realize the value. And in our situation here, we want to make sure that we can use the tools necessary and bring scale through those different complex models and tools that we have. And through that scale and the teams that we have, we can then drive that operational efficiency. And operational efficiency doesn't just apply to the tools and technology, it also applies to the people and the roles that are involved in that project. As I mentioned, you will have data scientists, data engineers, ML engineers. But in the case that I had with the grocery store was that we had IoT specialists, we had other vendors for the camera company, we had security people within the store because we had to connect to their data center and relay information to the cloud from each of the stores that we were testing that environment in. And so bringing those people together is an important part of that last mile. That operational efficiency helps manage the project, helps make it real and brings that value back to the business. And we cannot get into a situation where it's an us and them. There cannot be silos and finger pointing. It must be a collective effort to achieve that goal for the business. And bringing that operational efficiency, it helps also contribute to repeatability, to bring that consistency of process, behaviors, and the technology into that fold. And once you have that, then you can move to the next realization of actionability. Being able to, in this case, we need to be proactive and very timely to combat fraud. As the fraudsters get more sophisticated with their techniques to steal information and data and provide those corrective actions for our customer base. And so the scenario we will go through is that last mile, that value realization for that business and bringing those people together. The other important part in a real project is governance. In the projects that I worked on, the project manager would, with the customer, we would map out the timeline of the project from proof of concept through deployment. And then we would do the work back on that time scale and map out and do that chart of what is happening when. And that governance involved daily stand-ups with our core team of data scientist, engineer, and also the customer data scientist and engineer. We had an extended V team where in the company we met once a week to just check on the project. And then we had a weekly with the customer as well. Beyond that, we had the larger executive sponsorship team. We met with them once a month. And that was a check to make sure that everything was flowing on the timeline that we had set in the expectations of the project. And so you can see those different layers that add up and the complexity that is involved in bringing that efficiency to the project, to realizing that value and making sure that, it is a success at the end of the day. So, as I talked about, we're only two people, so we will not get into those multi layers of roles. I will play the role today of the ML engineer. I'll caveat this, I am not an ML engineer, but I will wear that hat today for the purposes of this scenario. My colleague Nina is a data scientist, so she will play that role, which is natural to her. And we will go through that process of creating the workspace. I will invite my colleague to collaborate. They will log in, they will go through that model upload and create that deployment pipeline. As the engineer, I will then do that due diligence and that health check to make sure that everything is running as it should and there's no issues with our pipelines or our models. We will then have an opportunity, because as I mentioned, you might have different models, to do that model switching in a hot swapping scenario. This allows you to switch the model in without dehydrating or recreating from scratch your workspace, your models and pipelines. And then we can show how we check for anomalies within those transactions that are taking place throughout the payment scenario. So to begin with, let me go into my workspace. And so as the ML engineer in Wallaroo, I have my workspace. I can see my default workspace. I have no pipelines or models running here right now. I do have a collaborator, and I can then launch a Jupyter Hub or other methods with which I can initiate this project. But to begin with, what I want to do is I want to create a workspace for this project and this environment. And so I can do this in a number of different ways. With the self-service toolkit, I can initiate this through the UI, API, or the SDK. Now, this is important because having that flexibility to give people the environment that they're familiar with to work in is important. We want to avoid having people forced into an environment that they're not familiar with. Then we have to retrain them, and then we have to delay them training and becoming familiar with a different behavioral approach when they know how to do it in a UI, for example, or an SDK. And that it lends itself to that operational efficiency contribution to make sure that we're efficient, we're running on time, and we're scaling. So I will create this workspace. We'll call it AI Camp for the purposes of this demo. And you can see here, I have no pipelines, I have no models, I have no collaborators in this space right now. So what I want to do is I want to invite the collaborators to my space so that we can start working on this project. I can see I have a number of people available to me. Again, in a real world, you might have multiple players in this area, and I will send an invitation to Nina. Now, what Nina will get through the community edition is she will get an email. Within that email, she will have a button that will say, hey, you're invited to collaborate on this workspace. She will then also have a temporary password. When she logs in, she will be prompted to change that password for security reasons to make sure that she has her own password to log into that workspace in that environment. So then I can see Nina is here. She's logged in and ready to go. And then what I can do is I can DM her, message her and say, hey, Nina, I see that you're in this space. I'll let you roll with the tasks that you need to go through, and then we can get this show on the road. So at this point, as the ML engineer, I'm going to hand it over to Nina to continue through her steps in the project. Nina?
Okay, great. So let me share my screen. Okay, so while the ML engineer has been getting the workspace ready for our deployment workspace ready, I, as a data scientist, will have been working on the appropriate models to detect our credit card transaction fraud. The idea with Wallaroo is that we would like our system to be agnostic, our deployment system to be agnostic to how the data scientist actually develops their models. In this case, I'm actually developing it in the Jupyter Hub that's attached to the Wallaroo platform, but I could be developing it in Vertex or Databricks or some other place. And we should be able to interact with Wallaroo no matter where it is. But for right now, I will do it here in the Jupyter Hub. I'm just going to load up some convenience functions and some libraries, import some training data. Yeah, there you go. Just quickly, we're going to look at the training data to see how prevalent credit card fraud is. In this case, it's fairly rare. We only have less than 1%. In fact, we have only 0.17% of the credit card transactions in this particular set are fraudulent. So that's actually pretty fortunate for us. So we're going to pre-process that data to get it ready for training. And now I'm going to train initial model. For this particular demo, I'm just going to make it a relatively simple. Keras model is just going to be a dense layer with a dropout in the dense. Obviously, in real world, we would do something considerably more complex, but for this demo, I'll just do something really simple. And I will train the model. Now, this is all kind of happening in parallel to the engineering side, the ML engineering and ML ops side, sort of making sure that things are ready for on the deployment side and the production side. And we're still training. Okay. And then obviously, once you've trained your models, you are continuously evaluating them, even at first on holdout data to make sure that they work properly, at least in the lab. So that you can pick a model that is the most appropriate and for putting in production and making sure that it meets your business goals. So here we're just going to show an example of just a quick evaluation of this particular model. This is probably not the best model in the world, but let's just say for now that it meets our business goals. So we think that this is a good enough model to put into production. As I said, I could actually just right now upload the model into Wallaroo, but as I said, I'm going to sort of slow it down and make this slow it down and kind of slow down the process so that you can see it. So what I'm going to do right here is I'm going to actually save off this model into a form that I can later upload into Wallaroo when my collaborator tells me that the workspace is ready. So here I'm just going to zip it up. Here I'll check that it's working. Okay, so now I've got a model and I'm calling it CC Fraud version 1. And what I'd like to do now, after Martin has told me that the workspace is ready, I can upload it to Wallaroo. So here I'm just going to do it in a different worksheet. I will upload all of the appropriate libraries, and some convenience functions. Martin showed you interacting with the workspaces through the UI. I'll show you how to interact with them through the SDK. So what I'm going to do here is I'm going to connect to the Wallaroo client and go to the appropriate workspace. And this is just making sure that my notebook is authorized to connect. Okay, so here you see that I've connected to the workspace, and you can see through the SDK that the workspace is empty. There are no models and no pipelines. So now I'd like to upload this model that I've just created to this workspace. For maximum interoperability, Wallaroo primarily works with models that are in the ONNX format. And this is because there's a lot of different training frameworks that are compatible with ONNX. And also ONNX is good for optimization of speed and performance. We at Wallaroo are working on building autoconverters so that you can take models that you've built in your different frameworks of your choice, and we can convert them to ONNX for you. So here is an example of converting this particular Keras model into our internal representation. So basically we have to set a bunch of different parameters that we need. And then we are going to convert it, simultaneously convert it and upload it. We're going to name it CC Fraud version 1, and we're going to upload it, convert it and upload it into the system. So now if I go to the UI and go to the appropriate workspace, you can see now that there is now a model in this workspace, CC Fraud version 1. And this is the first version of it. So now that we have the model uploaded into Wallaroo, we'd like to deploy it. And the idea here with Wallaroo is that it's often very difficult for data scientists and ML engineers to get together and do everything that needs to be done to get the data scientists' work up and running in production. So Wallaroo is meant to be a platform where we collaborate, and I can sort of deploy that model. The data scientists can deploy the model directly themselves when appropriate. So the way we deploy models in Wallaroo is through what's called a deployment pipeline. The simplest pipeline is just a model. The pipeline manages the endpoints of where the model gets the data that goes in to be for inferences to be made, and the data sync for where the predictions go. You can also do more sophisticated things with the pipelines. In this particular example, what I'm also going to do is I'm going to add what we call a validation rule. Validation rules are specifications of simple specifications of how we might expect the inputs into a model to behave or the outputs of a model to behave. For example, you might want to put a validation rule to make sure that if you expect the inputs to all be, say, positive in some domain, that you don't get negative numbers or nulls. The pipeline will keep track of whether or not those the inputs or the outputs obey the validation rules, and will log whenever those validation rules are violated. So in this example, I'm going to add a validation rule just for demonstration purposes that says I expect the prediction from the model to be less than 0.95. And the reason we're doing this is that if you have a transaction that appears to be very, very strongly evidence of fraud, that we might want to look at it for some reason. So we'd like our deployment pipeline to take note of those predictions and log them. So what I will do here is I will build a pipeline called CC Fraud Pipe. I will add my model to it, and I will add the validation rule that says I expect the output to be less than 0.95. And then I will deploy it. Yeah. And as I said, one of the things that the pipeline does is it manages the endpoints of the pipeline. And so you can see here that this pipeline has actually created a URL that external applications can now use to send data to this model and have predictions come back. We also have convenience functions in the SDK so that we can actually hit these URLs through the SDK with this command called infer from file. What I'm going to do is I'm going to send one request in just so that you can see that the pipeline works. And this is kind of the internal representation of what the inference looks like. You can see that it has records the original input data. It records what the output is, what the pipeline name is, the model. And if there were any failures, validation failures on this particular inference, there aren't in this one, it would also log those. So I can, since I put a validation check on this model, I can sort of quickly demonstrate how that works. What I'll do is I'm going to pass in some data into this pipeline, some of which I know are fraudulent transactions and some of which are not. And we'll have the pipeline do that. And then we can look at the logs. As I said, the pipeline keeps logs of everything, of all the activity that has gone through it. And so I'll just kind of look at the first few entries. And what we see here is that we have several inferences where the prediction was higher than 0.95, which means they violated my validation check. So they're marked here as being quote unquote anomalies. So then I can go back later, or somebody can go back later and check on these and see what's going on. You can also, instead of looking at the entire log of the pipeline, you could also just look at the only the anomalies by setting a flag for checking only for validation failures, which gives us this. So now we just get the validation failures. And you can have, since you can have multiple validation rules on a particular pipeline, this particular view of it doesn't necessarily show you which of the validation rules were violated, but you can actually look deeper into the individual log entries. And I will just look at the first one just as an example. And you can see that, in fact, what was violated, as we expect, was the expression that we expect the output to be less than 0.95. This is a validation because the output was actually 0.99. So as the data scientist, I can deploy the model into a production-like environment, and I can do some quick checks on it. Now, once the model has been deployed into production, it's now ready to take inferences from the real world. And for this example, for this demo, we will send some data streaming into the pipeline so that we can, here. Okay, so now we have data streaming into the pipeline, and I will hand this back to my colleague Martin to show what's happening once we've got the model in production.
Great, thanks, Nina. So yeah, you can see there that that handover between the two different roles, provisioning the workspace, inviting them to it, and then the data scientist goes through their tasks and steps. Now, as the ML engineer, we can see that before I didn't have any models or pipelines running, but now as Nina has provisioned those, I can see those in my console. Now, I can go in and see the model. And as I mentioned, in a real world project, you may have multiple models, and we have model versioning, which helps you track those and make sure that they are distinct from each other for, again, bringing that operational efficiency to the project. But I want to make sure now that this is running as it should be, that we don't have any issues with latency and so on. So first of all, I click into the pipeline and I can see that this is active and when it was deployed. I can then click into this and I can see my version history. As I mentioned, we may have multiple instances running here. And so I can check back on that version history. I can go into the metrics and I can see that the data is running through. So I'm getting the average request a second. So you've got about 112 here. And so this is well within the realm of our project. I can also have flexibility through looking at that data across a number of different, timeline opportunities as well, and dates. The other view that I have here is my inference latency. So I can see I have about 3 milliseconds. So, no latency issues here within this project and the data that's running. I can also view this in an enlarged view. But what we also do through the APIs is you can port this out to Tableau or another visualization of that data. So you have that flexibility in your organization. I can go into the audit log here, and I can check that this is the model version, this is the pipeline, and I can also see that throughput that is happening in this pipeline. So once I've done that, I will just go back, and within the space here, from a collaborative standpoint, I can leave a comment and say, all looks good. And I can send that back to my colleague so we can keep the conversation happening within this space and not be forced, have to open another window and type something in and so on. So at this point, I've checked, everything's running as it should be. I've let my colleague know that, hey, we're all good, latency and the health looks fine. And I'm going to hand it back to them so they can then take the next stage of testing out and hot switching a different model. So back to you, Nina.
Okay, so in the meantime, the model that I initially deployed is running and it's detecting fraud for us. But as the data scientist, I may be also monitoring what's going on with this model and looking at historical information and analyzing what's going on and trying to improve the model that we have. I might be trying to build a new model that works better than the one we currently have deployed. So let's say that while all this was going on, I have been working on training a better, improved version of this model. And I have one now, and we think it's time to upgrade the pipeline, the deployment pipeline. So I have a model here. I happen to already have it in Onyx format, and I'm going to upload this new model, which I'm going to call CC Fraud version 2, into the workspace that we already saw. Now that I have it, I want to put it in the pipeline. So what I can do is I can actually clear that pipeline, which will clear out the model that's already there, add this new model, and then re-add the validation rule that we had before and deploy it. Okay, and then what will happen is if we look at the pipeline, we can see that the pipeline now has CC Fraud version 2 running along with the validation check. Previous ones had version 1. We can see that, let's make that a better setting, that this pipeline, because it has the same deployment URL, will still be receiving queries. So you can see that it's still going on. We're still inferencing with this pipeline. There's maybe a little dip somewhere where the pipeline had to sort of temporarily slow down in order to swap the model. But everything is still going as it was. We can also check through the UI. I didn't show you this before, but you can check through the UI to see, if there are any anomalies, any violations of my validation check that have been occurring. And we can see that we've had so far, this is a cumulative view. So far over the last period of time, there has been about 15 or let's say 18 anomalies that have occurred. And I can actually drill down onto them in the UI the same way that I did in the SDK. And you can see this is the information, and here is the particular validation check that was violated. And you can also compare it with the output, which we can see validated violated the validation check. So that's kind of a somewhat simplified example of the training to deployment to upgrading process that Wallaroo is trying to make easier for both data scientists and ML engineers to collaborate on. And with that, I think I will hand it back to Martin.
Thanks, Nina. I'm just going to share up my screen again. So as the ML engineer, we've seen that Nina has been able to hot swap. You might have different models that you want to do A/B, canary, scenarios running through, and then it's also important for us to, at the end of the project, in our case, we want to undeploy that, so we're not burning unnecessary resources for the cloud billing folks. We don't want finance on our back, so we can actually deploy this and get those resources back and then reactivate it and rehydrate it again also for cost purposes. So what we've seen there is just a quick scenario of the collaborative effect of the data scientist and the ML engineer working in this single space, also in an environment that they are comfortable with. I worked in the UI, Nina worked in the Jupyter notebook from which she's comfortable in, and that, as I mentioned, helps that operational efficiency, that repeatability, and brings that scale to the project through managing different models and the pipelines and analyzing that data, and also the flexibility to expose that data to other applications that you may have invested in already. Now, just to, before we move on to Q&A, one thing that I mentioned earlier is that you can download the Community Edition. It's free. You can install it. You can play with this and other scenarios yourselves. And if you go into the docs.wallaroo AI site, you will see that we have a number of tutorials here that you can, pull in and unpack. You can go into the GitHub repo and grab all of them. And once you unpack them and open up your Jupyter notebook, you can see that you have them all here. And then you can, run in and then you can start sort of playing with them. You can go through a scenario like we did and invite colleagues to this so that you can get that hands-on practice and experience. So definitely encourage you to go through that. We have other resources available. We have a great docs repo available to us, as I mentioned, the tutorials. And also, I would love to hear from you. My email is at the bottom. If you join the community, I will invite you to our community Slack space. And I'd love to hear how you're using the technology, the product, projects that you're working on, but also feedback. We are a startup, and so it's important for us to get that feedback on our product and on our documentation so we can help improve the experience for you. So yeah, we will take the good, the bad, the ugly, so that we can make sure that you have that optimal experience and we can grow and learn through that. Again, thank you very much for your time. I know there's other things that you can be doing with this hour, but thank you very much for spending the time with us and today, and we'll hand over for some Q&A.
Great, thanks Nina and Martin for go through the project. It's really interesting to using different roles, put us into the different role to how to solve those problems. So I see some questions in the chat. Just to remind, now it's the Q&A. If you have questions, feel free to put in the chat. Or if you want to speak to ask questions, you can raise your hand. I can unmute you. You can speak to ask questions too.
Okay, so why don't I take the ones that are in chat right now? And Martin, please feel free to chime in. Adriana asks, is the pipeline coming from the Wallaroo library? And where can we find documentation? Well, Martin has pointed you to the documentation, and I believe we make these decks available as well. Is that correct?
You do, yeah.
Yes. So that answers the documentation question. The pipeline, basically Wallaroo manages essentially a model registry and a pipeline registry. So once the data scientist has uploaded their models and created the appropriate pipelines, they are in the registry and can be called from there and basically deployed in the platform, and are now active. So I hope that kind of answers that question. Santosh asks, oh no, wait, let me get to Chris first. Chris asks, is it possible to retrain the model automatically with the new data sent in for inference? Unfortunately, no, not currently, not in the current version of the model of the platform. The platform does focus on the deployment side of the house. So we aren't doing so much with training at this stage. We may someday, but not right now. This is intended to be, in fact, a deployment technology which makes it easy for data scientists to take the models that they've trained and to deploy it to production or a production-like environment. I mean, obviously, you may not always want the data scientist pushing it to production immediately. There may be some other intermediate stage, but this gives ML engineers and ML ops a way to sort of manage this whole process, whatever the appropriate process is for your business, in a way that makes it easy for the data scientists to collaborate with them. Let's see. Oh yes, Santosh's question was, where is the data coming from in the Wallaroo system? The deployment pipeline sets up a REST API. Basically, it's a URL that outside applications can then hit with queries that are sent to the model. So for example, if in production you want this model to be taking input directly from, say, a external website or something, you can manage that that endpoint so that the data gets sent from wherever you're getting it to into the model. We are also working on having more batch-oriented data connectors so that you can actually, schedule readings of data from your appropriate databases or data stores, and do kind of more batch-based inference scenarios.
We had one question from Chris about, is this a deployment technology or is it just for development? So it is for deployment. It is for that last mile to take your experimental AI, into that industrialized AI and realize the value of that data. You could also use it as a development as well, as part of the longer project. As you move through that experimental phase into deployment and rolling out that project for live. Could you answer the GitHub question?
Yes. So we don't really currently have that integrated, the platform integrated in that way tightly. So it's not necessarily a scenario that we've envisioned, although I mean, I think it would be a pretty cool feature to be able to do that, kind of a more continuous loop. So no, not yet. How about copy and John Wallback asks, how about copy and pasting data into a new version in a way that can be updated? I'm not quite sure what you mean, John. So if you would be able to kind of clarify that question for me, either verbally or in the chat, that would be great. Okay, how different is Wallaroo? Sorry, who just asked that? Sorry, the chat is scrolling as I'm looking at it, so it's a little hard for me to keep track. So I'm going to answer these questions in order that I see them in the chat. Is there model, Chris asks, is there model tracking capabilities as well, hyperparameter tracking, et cetera? No, there are not. As Martin said, this is primarily the deployment side. So we do not manage any of the obvious complexities of the training side yet. If you have another framework that does that for you, the idea is that we would like to be able to integrate Wallaroo with that framework that manages it. And the reasoning here is that particularly in a larger organization, different data science teams may actually use different frameworks to train their models because their models are all, doing different things. But we would like to be the unified deployment platform, which all data science teams throughout the organization can use to deploy their models into the organization's production system. So again, we're trying to be very agnostic about training frameworks, training methodologies. So we're pretty hands-off about the training side. This is focusing on what we're calling the last mile of the process, which is the deployment. Okay, so how different is Wallaroo from Apache Spark and Spark ML? Again, what I'm going to say is that we are not only training agnostic, but we are also sort of cloud and platform agnostic, which I think is something that we kind of forgot to emphasize in this talk. We want to be able to work with whatever infrastructure your organization already has. So whatever cloud or on-prem system you use, Spark ML is for Spark. We can work with things that are not Spark. So that's kind of where we see our value, is that we try to be very agnostic to what framework the data science teams in different organizations use. Is there alerting? Yes, there is alerting. Sorry, that was Jay Espinoza asked the question, is there alerting? And there is alerting. So yes, we have, I didn't show it here, but there are mechanisms for attaching alerts to those validation rules, so that, one of the ideas we have is that if alerts and anomalies will occasionally arise, you don't necessarily want it to be like directly alerted every time, but you can set up rules that if, say, for example, too many alerts happen within a given time period, or too many of a certain kind of validation failure happen, that we can actually directly alert a responsible person, whether that be a data scientist or an ML engineer. That can be, and that can be done, or a set of people. Okay, let's see. John Wallback says, is there an easy AK intuitive way to update retraining with new data by simply creating a new version? I think if I understand you, you can, if you want to be able to retrain by having, by seeing the real world data that has come through the system, you can actually go through the logs and get historically what all of the queries that have gone into your model for a period of time have been. So in that sense, you can get fresh data. We don't necessarily have ground truth for all of those inferences directly integrated in with the product. So there would have to be some other external way for you to sort of align the queries that come into the model with any ground truth for retraining. So there's still an extra step that would be required for doing that kind of loop. Jay Espinoza says you have to have parity between prod and training environments. How do you help figure out any disparities? Yes, there has to be a certain amount of parity. Basically, one of the value adds that we have, that we think we have, is that when the data scientist is designing their models, one of the things they're doing is they're taking the data, whatever it is, and they're often doing some amount of feature engineering data cleaning, et cetera, et cetera, et cetera on it. And one of the features that we have that unfortunately we did not demonstrate in this particular demo is the ability to basically have the data scientists transfer those, let's call them pre-processing scripts, into the production system. And the reason that we want to do this is that it's often the data scientist who has the best idea of what the proper feature engineering and data cleaning, et cetera, processing should be. So we would like them to be able to directly put those processing scripts into the production pipelines when that's feasible. And that helps, doesn't necessarily completely eliminate all disparities, but it minimizes, it makes it a little easier for you to match the production and development systems. Chris asks, what is the near term for Wallaroo as far as new features added? What we're working on while we're smoothing out our last mile stuff is we are also working on what comes afterwards in terms of production observability of these models. And I have talked about these a little bit in previous webinars here in AI Camp. In addition to the very simple validation checks that I've shown you, we are working, or we have in an early version of a monitor looking for data and distribution drift on the inputs and outputs to a particular model. The idea being that this data drift is an early indicator, can be an early indicator of concept drift, can be an early indicator that you need to retrain the models. So we have added some functionality where the data scientist can actually monitor these models in production through that UI that you've seen, and also through the SDK, and look out for signs of data drift that may indicate it's time to retrain the model. We're also looking to add a model explainability, so that when you have sort of strange predictions that you don't quite understand, to be able to go back and use the production data to try to explain why the model made the particular prediction that it had. Model explainability is something that a lot of people do during training to understand that, that their model is actually looking at the correct thing, and that's entirely appropriate. Our argument is that you should also do it have that ability available in production for sort of, debugging and auditing and diagnosis purposes. And that looks to be all the questions in the chat. And thank you, Chris, for congratulating us on Space Force.
Thank you. And thanks everyone for the feedback in the chat. I know that sometimes the chat forum or audibly is not everyone's comfortable with that. As I mentioned, please, want to make sure that if you have any questions, you can email me. We also have community@wallaroo.ai. So if you're not comfortable asking a question here, you can, contact us directly, and we'll get back to you and make sure that we help answer your questions. So again, thank you very much for your time. Please, if you want to go try this in some of those tutorials, I saw Bill mentioned you have study groups. This might be a great environment for your study group to, collaborate with each other and get into that role playing with the community edition and the tutorials. Bill, I'll hand it back to you.